Welcome to our lesson. Today it's on gas laws, specifically Charles' law by Teacher Mercy. Hope you're going to enjoy the lesson. Charles' law deals with the relationship between volume of a fixed mass of a gas with its temperature at a constant pressure. So unlike Boyle's law, which dealt with volume against pressure, in Charles' law we are going to deal with the volume of a gas relating to the temperature at a constant pressure. Now, we realize that the relationship between temperature and volume of a fixed mass of a gas is summarized in Charles' law, which states the volume of a fixed mass of a gas is directly proportional to the absolute temperature, its pressure being kept constant. That is what Charles' law states, that the volume of a given mass of a gas is usually directly proportional to the absolute temperature, its pressure being kept constant. Now, this law implies that the volume of a fixed mass of a gas increases in the same proportion as the absolute temperature, provided that the pressure remains constant. So if the pressure does not change, then an increase in volume leads to an increase in the absolute temperature, and vice versa. Now let's have a look at this relationship here. When the volume is small, the temperature is also small. In this case, we are referring to the absolute temperature. As the volume increases, there is also a direct increase in the temperature, all the way to the highest volume it can ever have. Then the temperature is also at its highest. And remember, we are talking about absolute temperature. I will explain absolute temperature as we move on. Now, mathematically, Charles' law can be expressed as shown below. Volume is proportional to absolute temperature. This can be shown like this. So, volume is proportional to absolute temperature. Now we can use the initials V and T, whereby we say volume is directly proportional to temperature. Now we can remove this symbol by equating and then introducing a constant, so that we can say volume is equals to KT over T over T. V over T is equals to constant K. So this is a constant. Then, given two conditions of volume and temperature, that is V1, V2, and T1, T2, then according to Charles' law, then this one, V1 over T1 will be equal to V2 over T2. So we can be able to use this expression to solve any mathematical problem involving volume and temperature. Now remember, this is happening at constant pressure, at a constant pressure. Now, some sample results of volume of a fixed mass of a gas with its temperature are as shown in the table below. Now, in this particular table, we have values of volume in centimeters cubed versus temperature in degrees Celsius. So you realize that an increase in volume, according to the table, is directly increasing the temperature too. Let us see how the graph is going to look like. Now, look at the graph. It is a straight line cutting the x-axis at negative 273 degrees Celsius Yes, and that is how the graph of Charles' law is represented. It's normally a straight line which passes through negative 273 on the x-axis. Now, let us interpret this graph. A gas whose volume is theoretically 0 at negative 273 degrees Celsius is referred to as an ideal gas. So the gases which behave according to Charles' law are ideal gases. Now, in real sense, a gas would have turned into a liquid before it reaches that temperature of negative 273 degrees Celsius. But theoretically, we are saying a gas which behaves in such a manner that at negative 273 degrees Celsius, the volume is assumed to be 0, then that is what we call an ideal gas. Now, the temperature at which the volume of a gas is assumed to be 0 is called the absolute temperature. From the absolute 0 temperature, that is where we get the absolute temperature scale. We derive the absolute temperature scale from the absolute 0 temperature. Now, the lowest temperature on the absolute 0 scale is 0 degrees Kelvin. The Kelvin is the SI unit of the temperature on the absolute on the absolute scale. The equivalence of negative 273 degrees Celsius on the Kelvin scale is 0 degrees Kelvin. Therefore, that is the lowest temperature that the absolute 0 scale can ever have. 0 degrees Kelvin equivalent to negative 273 degrees Celsius. Now, temperature interconversion from one scale to another is done as follows. Now, in order to be able to convert temperature in degrees Celsius to Kelvin, then we normally add 273 to the temperature that is given in degrees Celsius. For example, to convert 204 degrees Celsius to Kelvin, then we add 273, and we end up with 477 degrees Kelvin. Then to convert temperature from the Kelvin scale to degrees Celsius, we subtract 273 degrees Celsius. In other words, we do the opposite, which is subtraction of 273 degrees Celsius. For example, if you want to convert 4 or 5 degrees Kelvin to degrees Celsius, then you subtract 273 and you end up with 177 degrees Celsius. Now from there, we can look at some worked examples. For example, a gas occupies 450 centimeters cubed at 27 degrees Celsius. What volume would the gas occupy at 177 degrees Celsius if its pressure remains constant? In this question, we have been given the volume and the temperature as the initial conditions, and we are supposed to look for the volume of the final conditions. So we are going to say, according to Charles' law, V1 over T1 is equals to V2 over T2. But remember, we said volume is directly proportional to the absolute temperature. So we are going to change our temperature from degrees Celsius to degrees Kelvin. And we've said we do so by adding 273. So adding 273. So this one is going to give us 27 plus 273, 300 degrees Kelvin. And the other one will be 177 plus 273, gives us 450 Kelvin. So let us replace those values in our formula. So this is going to be 450 over 300 is equals to V2 over 450. So we can cross multiply this so that we have volume 2 will be equal to 450 multiplied by 450, all this divided by 300. This goes, this goes, this goes, this goes by 3, 1 by 3, 1, 5. So 15 times 45, 15 times 45 equals 675. So our volume 2 will be 675 centimeters cubed. Question number 2. At a temperature of 57 degrees Celsius, nitrogen gas occupies a volume of 750 centimeters cubed. At what temperature will the gas occupy 100 centimeters cubed? Express the answer in degrees Celsius. Now in this question, the initial conditions are a temperature of 57 degrees Celsius, volume of 750 centimeters cubed. And the question is, what will be the temperature when the volume is changed to 100 centimeters cubed? So according to Charles' law, V1 over T1 is equals to V2 over T2. Then you always remember that temperature has to be in degrees Kelvin. So we add 273 to convert to degrees Kelvin. So this is going to be equal to 57 plus 273 gives us 330 degrees Celsius. So V1 is 750 over T1, which is 330, multiplied by V2, which is 100, over T2, which we are looking for. Sorry, this is equal to. So we cross multiply such that T2 will be equal to 330 multiplied by 100, all this over 750. So our T2 will be equal to 330 times 10 is 3300 divided by 75. So this gives us 44 degrees Kelvin. But in the question, we've been told to give our answer in degrees Celsius. So what we do in this case, we take 44 degrees Kelvin, subtract 273 degrees. And this is going to be equal to 44 minus 273, negative 229 degrees Celsius. So that is the answer for this particular question. Draw a sketch graph to illustrate Charles' law. In this question, we are required to draw a sketch graph of Charles' law. So this is how we go about it. You have the vertical scale, which represents the volume in centimeters cubed, and the horizontal scale, which represents the temperature in degrees Celsius. Then we shall have the graph cutting the horizontal scale at negative 273 degrees Celsius. Just that.